Good morning, everybody. My name is Miklos Kromler. I'm the Hungarian ambassador of Hungary to Morocco here in Rabat. We welcome our prestigious guest speakers and, of course, the online attendees to our sustainability webinar, putting in highlight the high-level International Sustainability Expo and Summit, the Planet Budapest 2001. This summit is under the high patronage of the President of Hungary, Mr. János Áder, and it will be held between 29 November to 5 December 2021 this year. So first of all, let us start our webinar with a short video about the summit.
Our planet is our home. It nourishes, vitalizes, and delights us. We want our children to know it the same way. Let us protect it. Let us care for it. Planet Budapest 2021 Sustainability Expo and Summit.
Thank you very much for this video. We are very pleased and hopefully a lot of us from the world can join this Sustainability Expo. So today here we have several Moroccan and Hungarian experts of sustainable development. Let me present first of all Ms. Mona Alami, the CEO of Ecofertil from Morocco, Dr. Vince Lang, PhD, CEO of Discovery Center, Dr. László Alexa, PhD, CEO of Proficom from Hungary, and Dr. Rachid Aboutayeb, PhD, Food and Agro-Environmental Scientist of INRA. The goal of this debate is to discuss sustainable development solutions, green economy, waste valuation, and more than that, raise awareness of composting and environment protection. Hungary and Morocco already achieved great results in the field, and of course, both of the countries are following the Sustainable Development Goals described in COP21 in Paris. In this matter, I believe we have a lot to exchange on the scientific level, but it is very important as well to involve the business sector, the private sector. The sustainable economies need circular economy development and concrete actions for a transition to a greener economy. That's why Hungary is organizing the Planet Budapest 2021 Sustainability Expo and Summit to involve all the stakeholders and to show the achievement of Visegrad countries of the CEE, Central and Eastern Europe region. The main sectors will be presented in Budapest, such as water management, transport, food production, energy and waste management, and smart cities. And of course, the Expo will even raise awareness among young generations for sustainable development. The Hungarian Embassy in Rabat is organizing, in this view, several concrete actions of composting, waste management, and education of young generation. We are very pleased that our partners are in these projects. Orphelina d'Artifel in Marrakech, École Primaire Chib in Marrakech, Centre d'insertion et d'aide par le travail in Salé, École Al-Makrizi in Temara, Tazota Ferme Pédagogique in Temara, and the cooperative at the Wafuk. And the institutional partners are Wilaya of Rabat, INRA, Ministry of Energy, Mines and Environment, and the Prefecture of Skirat Tamara. In these partnerships, thanks to the Proficom Hungarian company, we will offer a composting system with a complete waste management solution. This last one is proposed by the Attawafuk cooperative, which ensures the treatment of selective waste, such as plastic, paper, and glass products. You can, of course, follow our projects on the Embassy's Facebook page during the upcoming dates. So for today, the debate, let us start. I would like just to give a short program how we will proceed. Each of the experts will give a presentation, and of course the online attendees can raise in the chat room few questions and we will try to answer them. So let me immediately pass the floor to Dr. Rachid Aboutayeb, who's a scientist of food and agri-environmental field of INRA, and of course the debate we can initiate immediately after your presentation. Professor, the floor is yours. Thank you.
Yeah. Thank you, Mr. Chair, for giving me the floor. Thank you for the audience for joining us in this event. So let me give me one instant, please, to share my presentation. Okay, let's get started. Okay. Okay, first of all, let me introduce myself. I'm engineer. I'm Rachid Aboutayeb, engineer in food industry. I got my PhD in agro-environment, and currently I'm a researcher at INRA, National Institute of Agricultural Research, Regional Center of Stade. My presentation is entitled Composting of Organic Waste and Food Safety. Are they connected? So during this presentation, we will try to answer this question, and we will try to establish the link between composting science and food safety. My talk will be in 5 parts. Okay, beside introduction, we will introduce some principles, some basics about composting science, and then we will take another view of food safety. And in the 4th part, we will try to establish the link between food safety and composting sciences. And by the end of this presentation, we'll conclude and make some recommendations. Nowadays, as you know, biowaste production is increasing worldwide. There are a huge amount of biowaste that are produced every day around the world. And our natural resources are polluted due to those organic waste, mainly water, soil, and air. And atmosphere. Okay, there are several kinds of hazards, such as chemical compounds like pesticides, foreign materials like grass pieces or things like that, bad smells, pathogenic microorganisms considered as biological hazards like Escherichia coli, Staphylococcus, sulfate-reducing anaerobes, and other microorganisms. So, valorization of organic waste becomes a mandatory action to deal with the environmental issues, and we need also to find a solution, sustainable solution, to deal with those huge amounts produced every day in terms of organic waste. That's why we are thinking about an accessible and cheap technique, which is composting process. It remains an accessible and cheap, less expensive technique compared to other techniques to valorize those biowaste. However, the presence of different hazards implies a methodological approach to prevent and to reduce at an acceptable level, or even to eliminate those hazards. That's why food safety should get involved to get out and to avoid those hazards in order to offer for the customer safe food or safe products. The objective of this speech is to establish the link between biowaste valorization using composting process on one hand, and on other hand, food safety. Let's jump on the first main part regarding composting science principles. Nowadays, as I mentioned before, there are about 2.6 million metric tons produced every day of organic waste, and we expect to reach about 4.6 million metric tons a day by 2015, according to biocycle.net, which implies the need for treatment to address pollution problems and to recycle organic matter. And we believe that composting technologies could constitute an effective solution. The question is, what is composting? Composting is a bioxidation process that involves the mineralization and humidification of organic matter, according to Zicconi et al. And we need microorganisms to perform this process. There are 2 kinds of composting, anaerobic one and aerobic one. For the aerobic composting, the decomposition process requires oxygen to degrade the raw material, and this operation is carried out by aerobic microorganisms that produce stable organic matter, carbon dioxide, biomass, and thermal energy. The second kind of composting is anaerobic composting. It takes place in the absence of oxygen, where biodegradation is carried out by anaerobic microorganisms producing methane, organic acid, and hydrogen sulfide. In this slide, we will we are seeing the flow chart of composting process. Now, composting process requires organic matter as a raw material, requires water also, and require bringing oxygen. So when we bring all these elements, we are boosting composting process. However, it could produce carbon dioxide, heat, and water. By the end of this process, we get stable and mature compost containing nutrient, microorganisms, and stable and mature organic matter, as I said before. In this slide, we can highlight about both drawbacks and benefit that you can get from composting science. When we have food waste as a raw material and we throw them directly to the land in the landfills, we are inducing a kind of pollution due to leaching of some minerals, generating some bad smells, generating greenhouse gases emission like methane, ammonia, and carbon dioxide, nitrous oxide. However, when we valorize those biowaste through composting, we are converting this raw material, a source of pollution, potentially a source of pollution, we are converting it in a stable organic matter, in a real resource that could serve for improving soil fertility and also improving crop yields. For the composting process, there are two main phases. First one is called bio-oxidative phase, and second one is called maturation phase or curing phase. For the first one, it could be divided in three main subphases: mesophilic subphase, where the bacterial and fungal mesophilic flora degrade simple sugars, amino acid, and protein, thus inducing a rapid increase in temperature, which is very, very beneficial to destroy pathogens during thermophilic subphase. And then, regarding maturation phase, it takes about 2 to 3 months, to stabilize the organic matter in order to give fulvic and humic acid, which is very important to make richer our soil and to boost the fertility of soil. In this slide, we have this figure that sum up the whole phases of composting process, and also it highlights how temperature evolves during time of our composting process. So after any process, we need to assess. We need some criteria to assess our process. And to assess a compost process, we have three kinds of parameters. It could be physical parameters such as organoleptic properties, odors, and temperature. Chemical parameters also, the pH should be around neutrality, mineral and nitrogen. More we have nitrate, more we have mature and stable organic matter. The carbon to nitrogen ratio should be beneath 15, and the humidification, we need to assess fulvic and humic acid in order to highlight how important is the end composter that we have produced. The third kind of criteria that you can use to assess composting process are biological parameters. So pathogenic microorganisms should normally be destroyed during thermophilic phases, which is very important to produce safe products. Another criteria in terms of biological parameters is phytotoxicity. So we can assess also GI or germination index. When we have germination index above 80%, we can talk about non-phytotoxic compost, which means that we have mature compost that could be used safely without any phytotoxic effect on plant. The second main part is food safety. So during this part, we will discover what is food safety. Okay, it's the first question that comes to our mind. Food safety could be defined as a scientific discipline describing handling, preparation, and storage of food in ways that prevent food-borne illness. All of us around the world are suffering of food-borne illness. And what we need, in fact, we need to ensure safe product in order to ensure food security. So, because I believe that there is no food security without food safety. And we have also another definition gave by ISO 20000. Food safety is the concept that food will not be injurious to the customer at the point of consumption when it is prepared and or eaten according to its intended use. So the compliance to food safety becomes a mandatory thing in order to ensure the production of safe products from the farm to the fork. Another question that comes to our mind, who is concerned by food safety? So I think all of us are concerned by food safety. Food safety is everyone's business. All of us, we are aiming to afford a kind of healthy lifestyle, and we can't have a healthy lifestyle without a healthy diet, and we can't have a healthy diet without food safety. That's why we should be aware, all of us, about food safety. However, there are three kinds of hazards which food safety should deal with. Biological hazards, including bacteria, parasites, fungi, and viruses. Chemical hazards also could be a real concern due, for example, to high level of pesticide or even some chemical contaminant like machine oil or stuff like that. This third kind is physical hazard. Sometimes we can find some glass pieces or metal in a food which could be very harmful to the consumer. We need to recognize also that food safety is kind of multidimensional concept, and we need to take into consideration different things about hygiene. We should apply some good hygienic practices, good manufacturing practices. We should also assess all the hazards that could be presented by our raw material, and we should also have a quality management system, for example, HACCP or hazard analysis and critical control code, in order to ensure kind of safe product by the end of the process. So, as I mentioned before, food safety remains a critical issue with outbreaks of foodborne illness resulting in substantial cost to individuals, the food industry, and the economy also. Because when we are losing in terms of food safety, we are losing in terms of economy, because we can get foodborne illness, and that's why we are compromising our economy growth, especially for developing countries. Food hygiene could be defined as the condition and measures necessary to certify the safety of food from production to consumption. And HACCP, or hazard analysis and critical control point, is systematic preventive approach. It's approach to prevent occurrence of hazards. So, regarding raw materials, basically raw material means anything that is or once living can be composted. So every living being could serve as raw material for composting. I mean by that plants, fruit, vegetables, flowers, or olive meal pomace. It's byproduct of olive oil industry, and technically all biowaste could be composted. However, we should adapt our process in function of the raw material. For example, animal-based material could contain a lot of pathogenic microorganisms. That's why we should be aware about that in order to deal with those biological hazards. Raw material can harbor pathogenic microorganisms like sulfate-reducing anaerobes, such as Clostridium, Escherichia coli, Staphylococcus, Salmonella, coliforms, and stuff like that, which implies probably biological hazard and unsafe end products. So in this third part, we'll try to establish the link between composting and food safety, which is very important. So as I mentioned before, the hazard occurrence from a food safety perspective, compost can be a hazard because it could contain pathogenic microorganisms which could bring harm to the consumer. And hazardous compost, when we have an improper composting, we can get immature compost containing, still containing some pathogenic microorganisms, which could be a source of foodborne illness. That's why we need to establish a methodology or a strategy to deal with those hazards. Let's begin with physical hazards. How to deal with physical hazards. To eliminate all physical hazards, we need to use a sieve or waste sorting to remove all foreign objects, such as broken glasses, pieces of wood, stone, metal part, and stuff like that, in order to offer a compost free of any foreign material. The second kind are chemical hazards. To prevent chemical hazards, in this presentation, I will focus more on pesticide, because pesticide could be carcinogenic, and we should have control on pesticide level in our food. That's why I'm focusing more on pesticide. We can prevent chemical hazards due to pesticide residue. But how? Compost could bring two mechanisms to deal with pesticide in soil. The first one is that could allow to sort and to retain those pesticides in soil, which is very important, because it will stop, it will reduce their bioavailability to get taken or uptake by plants, and that we are producing, that we are protecting the final consumer. Compost also could affect pesticide degradation, because it could, due to their biological activity, it could contribute significantly to degrade those pesticides, which is very important to guarantee and to ensure safe food products. The third and the final hazard are biological hazards. To reduce biological hazard to acceptable level, we need a proper composting system. We need to have control on our on how we monitor our composting process in order to reach a higher temperature, about above 55 degrees Celsius. And believe me, when we monitor properly our composting process, we can get even 65 or even 70 degrees Celsius, which is very important to destroy pathogenic microorganisms. The result is a significant reduction of pathogen population and sanitized compost. And the following slides will show, and we will highlight some finding of in the light of some previous studies about sanitizing of raw material during composting process. For chicken manure composting, for example, it was a significant reduction of Enterobacteriaceae, C, fecal coliform, Escherichia coli, Staphylococcus, and also significant reduction of anaerobic sulfito-reducing. The same thing was observed for Turkey manure regarding Staphylococcus and yeast and molds, and also sulfate-reducing anaerobic. A recent study. This article was published last month. Okay, and where we have we had highlighted significant reduction of Escherichia coli and Escherichia coli, Staphylococcus, and anaerobic sulfito-reducing. Highest temperature were between we have reached about 55 to 63 degrees Celsius during 2 weeks on average. It causes thermal destruction of microorganisms. So, and to apply food safety, we need a quality management system. That's why, we are introduce here the PDCA flow chart or plan. It's called also the mean wheel. Okay, PDCA is an acronym: plan, do, check, and act. Okay, we need to prepare a hazard plan to implement this plan. Okay, and to check it whether it is properly monitored. And also, we need also to improve our process to guarantee kind of continuous improvement. And the following slide, will give some more details about that. So for the hazard plan, we need to conduct a hazard analysis to check all the hazards, potential hazards that could be caused by the raw materials, to determine the critical control points and their critical limits, to establish record keeping and documentation process, which is very important. And then after our hazard plan is ready, we can implement this plan, and also we should have a laboratory to perform some required analysis, and then we can check whether our process composting work effectively and efficiently or not. And when we have some imperfection, we can improve through some corrective actions. Now, to conclude, we can say that proper composting process is essential. It allows to prevent, eliminate, and reduce the likelihood of hazard occurrence, which give us the chance to get safe products. And then composting process and food safety are closely connected to each other, and hazard implementation is an effective tool to manage the quality of the end compost. It's mandatory to ensure safe final products in composting factories. We recommend to develop a kind of clear vision, in order to manage bio-waste properly, to make an effective policy to deal with those organic waste produced and generated every day, in order to succeed our action plans, and in order to contribute to food safety and to serve the whole humanity. Why not? Thank you very much. I hope I was precise and concise. Thank you very much. Please feel free to ask your question using the chat box. Thank you very much.
Thank you very much, Professor. Let me immediately rebound on one thing, because it was very interesting that you link composting, food safety, organic waste, that we know that in our global world now it's a huge issue. And before that we go to Professor Alexa, I would like just to raise one very short question. You spoke about different types of hazards, chemical, biological, etc. So immediately, if you can just answer one question, because it was immediate in my mind, that what are the benefits that we can get from using compost as organic amendments? So I think it's very interesting. And after, of course, we will immediately jump to Professor Alexa. If you can just answer this short question to being in your presentation.
Yeah, it's very important. We are converting those bio-waste, potentially pollutant, in a valuable resource. And when we spread those stable and sanitized organic matter, we are increasing the soil organic matter, and thus we are increasing fertility of soil, and thus we are increasing crop yields. I think it's very important, because it allows to reduce using chemical fertilizers, which is very important to contribute directly to sustainable agriculture, which is very important, because I think nowadays global warming is one of the most important issues that humanity should deal with, and we need as scientists, we need to contribute by bringing effective and efficient solution to deal with those problems in terms of greenhouse gas emission, in terms of fertility decreasing, and in terms of sustainability in overall. So I think it's very important to adopt composting process, because it remains one of the most cheapest techniques that every farmer could afford it. That's it.
Thank you very much for this exhaustive and interesting answer. It was interesting, and I just wanted to share with you, even though I'm not a scientist, we have a small composting system in our garden here in Morocco. Yes, Professor Aboutayeb, if you would like to add something on that point.
Yeah, regarding educational programs, I can't agree more with Professor Lang, because it's very sensitive. It's very sensitive to take into consideration that the world is changing continuously, and we have to adapt our educational programs. So I think what we need to do is to perceive things in two different angles. So we can plan for short term, and also we can plan for long term. For long term, as Mona said before, mentioned before, that we should raise our children, the future generation, to be sensitive on about valorization of organic waste. But we need in short term, we need a solution, an effective and efficient solution. So I think in Morocco here, we have more than 50 schools and institutes that educate agricultural programs regarding livestock and regarding agriculture in general. So I think if we have the chance, to get to communicate with policymakers about adapting all the whole programs taken into consideration by waste valorization. I think it will be a solution for the short term in order to have at least technicians who are specialized in composting process or in bio-waste valorization in general. So those could contribute significantly to boost this sector. I think it's very important to have those kind of people surrounding us in order to make us able to valorize. As a scientist, we are sensitive that organic waste is a solution for a sustainable agriculture. But as Mr. Kromler, as you mentioned before, sometimes industrial think more about money. They are here to make money. It's a legitimate goal, and we need to find common ground between industrials and between environment in order to ensure sustainable development. And as you know perfectly, when we talk about sustainable development, we talk about social, economic, and environmental dimensions. So there are three dimensions that we should consider in order to succeed in this task. That's it. Thank you.
Thank you. If somebody would like to add something more, I have just one question, which is partly two questions will be. So usually when we see scientists and we see the world, every time we see a scenario that 2050 it will be worse, to 2100 it will be even worse. So give us some positive insights. What is your opinion, the tendencies, the perspectives for the upcoming years? And then my second question at the end I will raise, which I would like to just really a short one sentence answer at the end. But the first one is that what is the tendencies, what we can see in the world? Of course, somehow we see tendencies coming down, but I think tendencies should be stagnant or at least going up. So this is what I wanted to ask you as a scientist, that what you see in your field and what you are expecting in the upcoming years until, for example, 2050.
Thank you very much. So, as a scientist, we are very ambitious, and we are looking for a better world. That's why, based on the current data, we are forecasting. Maybe we are a little bit pessimistic because we are afraid that things will be worse in the future. However, what we are trying to do is to contribute as much as we can as a scientist, because I find it as a kind of a heavy burden on our children to share the information, to make people surrounding us sensitive about the problem, to highlight things about the real concerns that could constitute a real threat for humanity. So I think we need to score a positive thing before we die. But generally speaking, in terms of futurology, so based on current data, we need to react. So we are we are taking to aware others in order to react all together to save the planet. So we can't do it alone. But I think when policymakers are involved, get involved in, so we can do much better things, and we can turn this pessimistic scenario in an optimistic one. That's it. Thank you.
Professor, so let me just a little bit summarize at the end in my closing remarks, and first of all, thank you all of you for being here with us, and I would like to thank the attendees as well, online attendees in the chat room. They were a little bit giving a colorful discussion today to this debate. So as far as I understood, we have to bring together education, policymakers, business side, scientists, and we have to understand a little bit more our nature, maybe somehow to get back to our roots in the nature, but combining with the modern farming and finding a solution, a balanced solution. It was really great for me to see that Hungarian and Moroccan cooperation and scientists of these countries are thinking towards, of course, a better future, which can involve business sector, as I told you, and universities, education. I think this is the main achievement that I would bring with myself today. And once again, you can follow us, the embassy's Facebook page, where we have our composting projects posted regularly. Very soon, next week, we will start it with the partners, and we will be happy to share those experiences. And we are ready. Our representation is ready for sustainability proposals on business side, of course, universities, researchers. And finally, but not least, we are waiting all of the participants here today who are listening to us, that Budapest, Planet Budapest 2021 Expo and Summit awaits you in Budapest from 29 November to 5 December this year, physically. So I think it will be a great event, high-level event, combining business, scientists, of course, high-level attendees, ministers and presidents. So I think it's a great moment to get together. So once again, thank you very much for all. It was a great event, and I'm at your disposal. So please reach out to our embassy. And it was a really great discussion today. Thank you.